And now for a topic that people often are a little surprised about, confused about, and that is what does the with statement do? And then I also, I know people are often asked then to write some code that takes advantage of the with statement. Now, I'm keeping this purposely vague because there's so many different things you can be asked for, and I want to really cover a lot of the bases. So let's start with this. Most people encounter the with statement when working with files. It would be something like with open my file txt for writing as f. Okay, and then it will be something like f.write of abcd, and then f.write of efgh. Okay, so far so good. What's the big deal here? The big deal is now if I check what's in my file.txt, it has ABCD and EFGH. If I hadn't put this code inside of a with statement, those lines would not actually have been printed to the file. They would have not been sent to the file. What's going on? Why am I saying this? Because when you write to a file, when you open a file for writing, and then you write to the file, the data is not actually written directly to the file. Rather, it is written to a buffer in memory. And only when that buffer fills up is the data actually written, or the data in the buffer, what we call flushed to disk. And the idea is that if every single time you ask to write to disk, it actually did write to the disk, and I say disk, file system, whatever the modern term is, if we had to do that, then your computer would slow to a halt, constantly dealing with writing to disk. So what happens instead is that it's buffered. But then if you don't close the buffer, if you don't flush the buffer, close the file, then the data won't actually be written out to disk. Now that's not entirely true, because actually when Python exits, it will close the file, it will close the file object, and that automatically flushes the data. So assuming there's no blackout or technical problem, yes, the data will eventually be written to disk, but you probably don't want to rely on Python doing it at the end of its life. Rather, you want to rely on doing it when you want. And so with provides us with that. With allows us to say that here, automatically flush the buffer and close the file. And sure enough, if I now ask, hey, F, is F closed? Yeah, actually it is closed. I'll be told that it's true. So we opened the file in the top there, in line 4 with, and it was closed automatically. Now, how did this actually happen? The magic is thanks to a combination of with and the file object. So with here looks for an object, and here's a file object, that is known as a context manager. So context manager protocol means that an object implements enter, and an object implements exit. Okay, sounds good. Where are these used? Well, enter is executed. Enter is run at the beginning of the with block. And exit, as you can imagine, is at the end of the with block. So what's really happening is that with is taking this object here and assigning this variable to it. So far, so good. It's then running f.enter. I can just do that. And it's running f.exit. Well, it turns out that f.enter actually does very little, and f.exit does a lot. F.exit flushes and closes the file. That's how we know that it works. What if I want to take advantage of the with statement? And there are other objects that do this. For example, locking in threads and multiprocessing can use the with statement to start and stop a critical section. Many databases, if you want to work in terms of transactions, you can do a with on a transaction, and then it'll make sure that it's all atomic. So there are other objects that use with and that implement the context manager protocol. I still think that the vast majority of uses of with are with files, but that's not necessarily a bad thing. So how can we implement a class that takes care of this, or any code that uses this? Well, here I can do something like this. I can say class, let's say, log file. We'll say here def init self and file name. Self.file name equals file name. So far so good. And I can say def of enter self. And then we say your print now in enter. We say return self. And then I say def exit self. And then we actually have to take 3 other arguments. So I'm going to say here just args for now. And then we're going to say here print now in exit. So far, so good. And now, if I do something like this, now if I say lf equals log file of my log.txt, and now I can say with lf, I guess I could have just said here with log file my log.txt as lf. I think it's going to be a little nicer to write, a little more standard as well. Say print hello, and look at what happens here. It says now an enter, hello, and now an exit. So we see that our methods are actually being executed and executed correctly. What can I do there? Well, that's up to me. What I might want to do in this particular case, since it's a log file class, is open up the log file for writing and close it from writing. So how would I do that? Well, I would say here, let's say an enter, I could say something like this. I could say self.filename. Well, I could say here, self.f equals open self.filename, and we'll say it's for, actually we'll do appending here. Okay, and then what I can do here is I can say here self.f.close. Okay, well that's not going to be so exciting, but you'll see what we can add to it in a moment. So now when I do this, sure enough, get exactly the same response. Nothing too exciting there. And our file does exist. So I can do an ls-l of, what do we call it, my log.txt. We'll see that it has at least been opened, right? Just a few moments ago it was opened, it's 0 in length. But here's what I can now do also in enter. I can say something like this. I can say import sys. And then I can say here, self.old standard out equals sys.standard out. And then I can say sys.standard out equals self.f. Notice what I'm doing here? What I'm basically saying is that the standard out should be reassigned to old standard out. And then I should say self.f is going to be, like this file that I just opened is going to be put into sys.standard out. In fact, I don't even need to do additional things. I can just say here sys.standard out equals that. And then when I do that, we can see here, there we go. Now it's all good. But wait a second. When I exit from this, I don't want to be writing there anymore. So in exit, what I can do is I can say here sys.standard out equals self.old standard out, and then self.f.close to close it off. And what is that going to do? Well, now when I run my code, watch what happens. What does it print? Prints now and enter, but it doesn't actually print anything else. Well, what happened there? Oh, now it's going to get like says, oh, log file has no attribute f. What happened there? Oh, because I didn't have an f. Ha ha ha. So we actually don't need to do that. All right, let's do this here, and let's do this here. All right, and now it's going to say now and enter, and that's it. But if we look now in mylog.txt, we're going to see it has some text in there. What's in there? Mylog.txt. And we'll see that it says hello and now an exit, hello and now an exit. Now it has it twice because I ran this code twice, and I used A for appending as opposed to W for writing. Okay. And then basically what we see is that inside of this context manager, when I use log file as a context manager in this way, all printing, anything that would be normally sent as standard output, is instead sent to our log file. Pretty nifty. Okay, so this is how we can implement a simple context manager. Now you might say, boy, this is a lot to do if all I want to do is like, have something happen before and after some sort of code. And you might be right. Some people feel that way as well. For that, we actually have something known as context lib. I can say from context lib import context manager, long word. So here's what I'm going to do. I'm now going to take my stuff from here. Actually, I don't need to do this. I can just write it. All right, so now what's what I'm going to do? I'm going to say here def, temp use, temp reset standard out. And we're going to take here a file name. And now I'm going to say here old standard out equals sys.standard out. And then I'm going to say here sys.standard out equals open file name for writing. I'm going to say here print in enter. And I'll say this is 2 just so we can make a clear distinction between what we did before and now. And then I'm going to say yield. And then I'm going to say here print print in exit 2. And then what we can do is we can say here sys.standardout equals old standardout. Okay, well, what's going to happen now? Oh, actually, nothing's going to happen because I didn't use the decorator. If I say here context manager. Now, this is like coming together of several different worlds in Python. I have a decorator, and a decorator basically hijacks a function when it is defined and when it's running, and uses a different function or different callable in its place. This is not the place to talk about that. I'll have something else that talks about decorators later in this course. But basically, I'm also using a generator function here. And the generator function is a function that runs, returns a value in iteration, and then runs some more. It's like a function that goes to sleep in the middle. And so the stuff before the yield is basically like enter. And the stuff after the yield is basically like exit. And so without writing a class, I can use a context manager in this case. And now I can say exactly the same code as I had before. Let's just do this, except I'm not going to use the log file class. Rather, I'm going to use my temp reset standard out. I'm going to say here temp reset standard out. I don't even need LF there. And now when I do that, oh wait, it didn't like that. Enter. What did it not like? What did I do wrong here? Reveals context manager, and of course, print hello. And of course, let's see what if I do. This should not make any difference whatsoever. Okay. Let's just take a quick look. Context manager. It looks like it should be happy, but it is not. All right, let's try this once more here. Now it's still complaining. Temp reset standard and enter. Okay, here. That shouldn't make a difference. Oh, there we go. That did make a difference actually. Okay, there we go. I think it was having some problems with the file name that I was using. Cat mylog txt. Okay, and now it's very happy. What if I just do writing? I think someone else might have it open or something. I think that might be the issue here. No, now it's happy. Okay, there we go. There we go. So I don't know what I reset there, but something obviously wasn't happy before and now is much happier. So basically what we see is the stuff that's before the yield is what's happening in the enter part, and what's happening after the yield is happening in the exit part. When should you use a context manager function? When should you use the whole class? Sort of depends. I'd say if the only functionality that you have is the context manager, then implement it using this context manager decorator and the generator function syntax. But if you're trying to use your object within with, then the right thing to do is to add the dunder enter and dunder exit methods as we did before. All right. Sorry for that little confusion there, but actually I'm keeping it in the video. I'm not editing it out. In no small part because I think it's important to see this sort of frustration, debugging, and process, and not just say, oh boy, everything is always perfect. Okay, on to the next question.